Welcome to our maths revision session number 2 of day 1 of our revision, looking at probability part 2. And in this part I'm going to deal with binomial probabilities and Poisson probabilities. Let's just go back to our program and see how we are progressing with our intensive revision program. So we're still dealing with the day 1. And of course, the part 2 of the session 1 of our revisions, talking about probabilities. I told you that I'll break down probability into 3 different parts, and that means 3 different videos will be done on probability. The first video we did was talking about normal probabilities. Second video, this very video we are doing, is about binomial and Poisson probabilities, and the last video that will be done will be talking about simple probability concepts. So let's go into the heart of things and begin to look at probability distributions, probability distribution, Poisson and binomial probabilities. Let me remind you that there are 3 different probability distributions that are examined in our DA2 quantitative analysis subject for Zika program. So we have already looked at the normal distribution. We need to look at the binomial and Poisson. Let me also remind you of the challenge that you always have in an exam. That's the challenge of deciding which probability distribution to use at any particular point. Well, if you follow this video, I'll be able to clarify how you are supposed to decide which probability distribution to use. And what will help you decide appropriately which probability distribution is by understanding the characteristics of each of these probability distributions. So let's go into the heart of things and look at the characteristics for the binomial distribution. In a binomial situation, you need to have an existence of trial. A trial is either an experiment or something that has been gained or understood by experience. So the number of trials will be given, and binomial probabilities, of course, are used for discrete data. Discrete data is data that is only expressed in absolute numbers. For example, if you are talking about number of items, you are talking about number of people, you cannot have 7.8 people in the place. It's either there are 7 or there are 8 or there are 9 people or there are 10 people. Same applies to the number of items. So that's what we mean when we say discrete data. Discrete data that can only be expressed in absolute numbers. You don't have decimal places for that type of data. The third characteristics for the binomial is that you usually have only 2 possible outcomes. Those possible outcomes can be expressed in form of good or bad, okay or not okay, right? So though there are only 2 possible outcomes in any binomial situation. So let me run through the characteristics for the binomial. Number 1, you've got existence of trial. Number of trial is given. Discrete data is what we calculate binomial probability for, and there are only 2 possible outcomes. How do we calculate the mean? The mean is calculated as the sample size n multiplied by the probability. So the number multiplied by probability, that's the value for mean. Standard deviation can be calculated by looking at the square root of n multiplied by probability multiplied by q. What is q? If P is the probability of success, Q is the probability of failure. So how do you calculate Q? Q equals 1 minus P. The formula for binomial is probability of x is equals to n combination x. You find that on your scientific calculator, don't worry about it. N combination x multiplied by probability to the power x multiplied by q to the power n minus x. Q is the probability of failure, P is the probability of success. So once you have the probability of success, the probability of failure, Q, will be equals to 1 minus the probability of success. Let's look at the characteristics for a Poisson distribution. In the Poisson distribution, you have occurrency, not trial, but occurrency. The question is, what's the difference between trial and occurrency? Trial, the researcher might be doing something to get the results. Trial also can be referred to the conclusion you've made because of your past experience, or an experiment has been done and then you make conclusion from that experiment. That's a trial. Something has been tried out. For occurrency here, the researcher has done completely nothing to cause the results to happen. So nothing has been done from the researcher to cause the results to happen. That's occurrency. Things are happening by themselves. That's occurrency. The other characteristics of a Poisson is that a fixed time period will be given, and also Poisson are calculated for discrete data. And of course, Poisson is the best measure for probability when the probability P is small and N is too large. So at what point do we say the probability is too small? It's when it's less than 10%. At what point do we say N is large? When it's greater than 50. So if you've got even a binomial situation where P, the probability is too small, less than 10%, and N is too large, beyond 30, then you can approximate the probabilities by using Poisson distribution. Normal distributions are best used where the probability is not too small and N is large. So you may have a binomial situation where N is large, beyond 30, but the probability is not too small, it's greater than 10%. You can approximate the probabilities by using normal distribution. The mean for the probability is NP, N multiplied by the probability. Variance is the standard deviation squared. And the formula for Poisson is probability of X equals to the mean to the power X multiplied by exponential to the power negative mean divided by X factorial. So that's what you need to remember. Remember, I've already said one of the challenges you have is deciding which probability distribution to use for any particular question. So let's just practice that. By the way, this particular video only concerns those who are doing DA2 quantitative analysis for Zika. If you are doing 1.2, please forget, you will not be examined on the things we are going to discuss in this video. So what we are discussing in this video are only examined for those that are doing DA2 quantitative analysis. So let's go into the details of things, looking at the questions. So let's start with our first question coming from the December 2017 final exams for DA2 quantitative analysis. This was coming from section A 1.9. Suppose the average number of car accidents on the highway in one day is 4. What's the probability that no car accident what's the probability of no car accident in one day? Suppose the average number of car accidents on the highway in one day is 4. What's the probability of no car accident in one day? So the question is, what type of probability distribution is this? What type of probability distribution is this? What type of probability distribution is this? Think about it. I've already given you the guiding rules, characteristics. With the Poisson, you have occurrence. With the binomial, you have trial. So is this trial or an occurrence? Car accidents. In a trial, the researcher might be doing something causing the results to happen, or the researcher has observed over a period of time and again conclusion. I've made conclusions based on past experiences. But in an occurrence, things are happening without the influence of the researcher. So the question we are looking at, is this an occurrence? Number of car accidents, is it an occurrence or a trial? A trial also can mean experience, so can mean an experiment being done. So the number of car accidents is not a trial, it's an occurrence, it's something that is just happening without the influence of the researcher. So if we agree that number of car accidents is an occurrence, not a trial, then we conclude that we are supposed to use Poisson distribution to calculate our probabilities. So let's look at the solution. Poisson distribution to calculate our probability. What do we need? The formula. So pick the Poisson formula. Poisson formula. Say the Poisson formula, probability of x, probability of x equals mean to the power x multiplied by exponential to the power negative mean. So we have, let's write our formula properly. So that's the mean to the power x we have the mean to the power x multiplied by exponential to power negative mean. Like that. So mean to power x multiplied by exponential to the power negative mean divided by x factorial. Divided by x factorial. That one looks like x, but it's a multiplication sign. Let's use the dot to just create a distinction there. So exponential to the power negative mean multiplied by mean to the power x divided by x factorial. So in the question, what is the mean? According to the question, we've been given the mean equals to 4. The question says the average number of car accidents on the highway in one day is 4. So 4 is the mean. What's the probability of no car accident in one day? No car accident in one day. So no car accident in one day, we are looking at the probability of 0 car accidents in one day. So the probability of 0 is going to be exponential to the power negative 4 multiplied by 4 to the power x, which is 0, divided by 0 factorial. So what is 0 factorial? 0 factorial equals 1. Any number to the power 0 is 1. So what is exponential to the power negative 4? Pick a calculator, go to the second function, exponential sign, then punch negative 4. You should have 0.018 01832. 32 rounded off to the nearest whole number. So this is the exponential to the power negative 4 multiplied by 4 to the power 0, which is 1, multiplied by 1, it will be the same value, divided by 0 factorial, which is also 1, it will be the same value. So this is the correct answer. So the correct option for this question is option C. C is the correct option for that particular question. You'll find exponential key on your calculator. You'll find the factorial key on your calculator as well. So you can use your calculator to find those answers. Let me look at the next question. The next question coming from June 2018. June 2018 DA2 quantitative analysis. This was question 2 of that examination paper. A university found that 20% of its students withdraw without completing the introductory statistics course. Assume that 20 students have registered for the course this year. Find the probability that. Okay, so as usual, you need to, first of all, decide which probability distribution you're going to use. So, looking at the question, the university found that 20% of its students withdraw without completing an introductory statistics course. Is this a trial or an occurrence? The university management have found from past experience that 20% of that. So this is the trial. It's not an occurrence, it's a trial. So if this is a trial, we know that we are going to use the binomial distribution to find our answers. So let's start with the first question. Assume that 20 students have registered for the course this year. Find the probability that 2 or fewer. So 2 or fewer means that the maximum number of withdrawals is 2. So it can be 2 or less. That can either be 0 withdrawals or 1 withdrawal or 2 withdrawals. So we have 3 different possibilities, and these are mutual possibilities. So the solution for this question will be, so let's go to the solution. We're looking at the probability of x being less or equal to, x is less or equal to 2. That means x less or equal to 2. That means we either have 0, so probability of 0, or we have 1, that's the probability of 1, or we have 2, that's the probability of 2. Binomial probability formula. The binomial probability formula is probability of x is equals to n combination x. So we have n combination x multiplied by probability to the power x multiplied by probability of failure to the power n minus x. That's the probability formula, binomial probability formula. So we need to calculate that for 0, for 1, and for 2. So let's see how we can do that quickly. So the probability for 0 is going to be where there is n is the sample size. Let me just highlight those things. N is equals to 20, that's the sample size. P is the probability, so the probability is equals to 20%, 0.2. And Q, P is the probability of success, Q is the probability of failure. So that Q, the probability of failure, will be equals to 1 minus the probability of success P, so that will be equals to 0.8, or equals to 0.8. So those are the values that we can pick from the question. So items we can pick from the question. So let's conclude. So what is n? N is 20. So n is 20. X is, for probability of 0, x will be 0. The P probability is 0.2 to the power x. X in this case will be 0. Q is 0.8 to the power n to the power n, that is 20 minus 0. 20 minus 0. Plus the probability of 1 is the probability of 1 will be where there is x, you put 1. So 20 combination 1, 0.2 to the power 1, 0.8 to the power x to the power n minus 1. Okay, so for the probability of 2, where there is x, you put 2. Where there is x, you put 2. So you have 20 combination 2, 0.2 to the power 2, 0.8 to the power 20 minus 2. Okay, so that's what you have. Tap that in the calculator. So 20 combination 0 multiplied by 0.2 to the power 0 multiplied by 0.8 to the power 20 minus 0, which is 20, you should get 0.0112 plus 20 combination 1 multiplied by 0.2 to the power 1 multiplied by 0.8 to the power 19, you should get 0.0576, 0.0576 plus 20 combination 2 multiplied by 0.2 to the power 2 multiplied by 0.8 to the power 18, you should get 0.1369, 0.1369. So what will be your final answer? Probability of x less than 2 will be, add those values, you should get 0.2060. And that is your final answer. That's your final answer. So let's move on to the part 2 of the question. Part 2 of the question, find the probability that exactly 4 will withdraw. Probability of x equals to 4. Probability of x equals to 4 will be equals to, get the same probability, the same formula for the binomial. Probability of x equals to that. Probability of x equals to, that's the formula for the binomial. So where there is x, you're going to put 4. So to speed up my process, I'll borrow this expression here. So where there is x, put 4. The rest of the values will remain the same except for the x value. So the probability of x equals to 4 will be 20 combination 4 multiplied by 0.2 to the power 4 multiplied by 0.8 to the power 16. Your answer there should be 0.2182. 0.2182. And that is your final answer. Let's move on to the next question. Next question. Find the probability that the probability of more than 3 will withdraw. Probability of more than 3 is the probability where x more than 3, x is greater than 3. Don't use greater or equal to. This one is more than 3, so x is greater than 3. So what's the probability of x greater than 3? Look at the sample size. The sample size you have is 20 students. So if you are calculating the probability of x more than 3, you have the probability of 4 or the probability of 5 or the probability of 6, 7 up to 20. You are not going to have that time in an exam to calculate the probability up to the 20th probability. So what you need to do is, since you know that total probability equals to 1, if you say 1 minus the probability of 0, probability of 1, probability of 2, probability of 3, whatever will remain will represent the probability of 4 going up to 20. That's what we are going to do. So this one, you say 1 minus the probability, 1 minus the probability of 0, or the probability of 1, or the probability of 2, the probability of 2, or the probability of 3. Like that. So when you take the total probability, which is 1, minus the probability of 0, 1, 2, and 3, whatever will remain will represent the probability of more than 3, which is 4, 5, 6, up to 20. So we know what the probability of 1 and the probability of 0, 1, and 2. We summed up these probabilities into this value here. So that's the summation we have there. So we have no problem with those probabilities. We just need to calculate the probability of x equals to 3. So let's just do that. Probability of x equals to 3. Probability of x equals to 3. Where there is x, we'll put 3. Let me just borrow those expressions. We use them to speed up our process. Probability of x equals to 3. So where there is x, put 3. The rest of the values remains the same. The rest of the values remains the same. So this is going to be equals to 20 combination 3 multiplied by 0.2 to the power 3 multiplied by 0.8 to the power 17. This should be equals to so tap that into your calculator. You should have 0.2054. 0.2054. That's the probability of x equals to 3. So the probability of x being greater than 3, the probability of x being greater than 3 is going to be the probability of x being 0 plus it's going to be 1 minus the probability of 0, 1, 2, 3. So we have the probability of 0, probability of 1, probability of 2 combined into this value here. That's what we calculated there. So just copy that, drop it here. Plus the probability of 3, which is the value we've just calculated. Probability of 3 is this one. So copy that, push it here. That's the probability of 3. 1 minus those two probabilities, your final answer should be this and that put together, 0.2060 plus 0.2054. Your answer should be 0.4114. 0.4114. So what's the final answer when you subtract that? 1 minus that value, you should have a 0.5886. 0.5886. And that's your final answer. All right, let me deal with the last question on this part. Very simple question. It says find the expected number of withdrawals. The expected number or expected value E expected value equals to NP. The expected value is the same as the mean. It's NP, N multiplied by P. So what's the sample size? The sample size is 20 multiplied by, what's the probability? Probability is 0.2. So 20 multiplied by 0.2, you should get 4. So the expected number or expected number of withdrawals is going to be 4 withdrawals in that particular season. So that's how you're supposed to tackle that question. Let me look at another question. This question came in December 2017, final exam for DA2. Let's go through the question. Question 3. It is estimated that 55% of freshmen that are entering a program are certain to graduate from their college in 4 years' time. From a random sample of 6 freshmen, calculate the probabilities. So let's decide, is this a binomial or a Poisson? I want to give you 1 second to think about it. Is it a binomial or it's a Poisson? What characteristics defines the binomial? past experience, experiment. That is a trial being conducted. What do we expect of a Poisson occurrence? The researcher is doing completely nothing to cause the result. So what do you think? It's expected 55% of freshmen that are entering the program are certain to graduate. Is this a binomial or a Poisson? You are right. It's a binomial. If it is a binomial situation, then we know what to use. We'll use the binomial formula. Our n does not exceed 30. Our p is just okay. So let's use the binomial formula to calculate the answers. Let's start with the first part of the question. Solution. What's the probability that exactly 3 will graduate? This is the probability of x equals to 3. Where there is x, we'll put 3 in the formula. What's the formula for the binomial? Let me just copy down the formula for the binomial. For binomial, the binomial formula is this one. That's the binomial formula. So where there is x, we are going to put 3. What other things are we given? We are given the probability, which is 0.55, 55%. That's a probability. So Q, which is the probability of failure, Q is going to be equals to probability of failure Q is going to be equals to 1 minus P. That's 1 minus 0.55. This is going to be 0.45. What else do we need? We want the value of n. N is given a random sample of 6. So n is 6. So substituting those values into our formula, this is supposed to read probability of x equals that. So we substitute those into the formula. So let me just borrow something that we've already done here to just try and speed up the process. Let me borrow this one. Since we are looking at the probability of 3, so where there is x, we've put 3, 3, 3, 3. But the sample size is different. Sample size is 6. That's as per question. So the sample size 6. That's as per question. So tap that in the calculator. 6 combination 3 multiplied by 0.2 to the power 3. The probability is different. Sorry about that. The probability is not 0.2. The probability in this case is 0.55. And so Q is 0.45. My mistake on that one. All right, so 6 combination 3 multiplied by 0.55 to the power 3 multiplied by 0.45 to the power 6 minus 3. When you do that, tap that into your calculator, you should be able to get 0.3032. And that's your final answer. Next question. What is the probability that more than 4 will graduate? probability of more than 4 will graduate. So look at the sample size that we have here. The sample size is just 6. So more than 4 means the probability of 5 or the probability of 6 graduating. So you don't need to use 1 minus the probability of 0, 1, 2, 3 or 4 because that will be a longer route. The shorter route will just be get the probability of 5 and get the probability of 6 because the sample size is 6. So what's the probability of more than 4? Probability of x being greater than 4. X being greater than 4 will be equals to probability of 5 or the probability of 6. Why have we gone this route? It's because the sample size is 6, so we can't go beyond 6. So let me borrow what we have already punched here to get the probabilities of 5 and 6. So this is going to be equals to the probability of 5, the sample size here, the sample size is 6, but x is 5. So where there is x, put 5. Where there is x, put 5. Or the probability of 6, where there is x, put 6. Where there is x, put 6. Like that. So what do we have here? 6 combination 5 multiplied by 0.55 to the power 5 multiplied by 0.45 to the power 1, that is the 6 minus 5. You should get 0.1359. 0.1359 plus 6 combination 6 multiplied by 0.55 to the power 6 multiplied by 0.45 to the power 6 minus 6, which is 0. You should get 0.0277. 0.0277. So what will be your final answer? Probability of x greater than 4 is going to be equals to 0.1359 plus 0.0277. That is going to be 0.1636. That's your final answer. Let me do the last question for this particular session. What is the average number that would graduate from a group of 6 freshmen? The average number is the mean. And we also said mean is the same as the expected value. So what's the expected value or expected number to graduate? What's the mean? Mean is equals to NP. That will be equals to, what's the probability? What's the sample size? N, that's 6, multiplied by, what's the probability? 0.55. That's the P in our question, 0.55. Tap that in the calculator, you expect to have 3.3. Now remember what I said about discrete data? We're talking about freshmen graduating, so you cannot say 3.3 people who graduate. Who is the 0.3? It's not possible to have 0.3. So round off to the nearest number. So you expect 3 freshmen to graduate. That's our expectation. 3 freshmen will graduate. I want to encourage you that probabilities are not very, very difficult, more especially at our level DA2. It's very, very simple. Understand probability distributions and understand the characteristics that defines each of the distribution. But you will do well to practice these distributions because that will enhance your experience in handling probability distributions. I hope this video has helped you just a little bit. That's all you need. Keep on practicing and watch out for the other videos that will be coming after.